So today we have a cool geometrical problem. We have a semicircle, then we inscribe 7 congruent quarter circles inside it in this specific pattern as you can see in this diagram. Now the question is to find the ratio of area of these 7 quarter circles to the area of the semicircle. So let us see the solution. How can we solve for this? So first of all, we can see that the radius of this quarter circle and the radius of the semicircle is not given. We have to take it as a variable. So I will take the radius of this quarter circle. So I am writing it over here. So radius of the quarter circle, I will take it as equals to A. And the radius of this semicircle, so I will write like radius of the semicircle as equals to B. Now here we have taken the radius of this quarter circle as equals to A. And as it has been given that these 7 quarter circles are congruent to each other. So they all have a radius that is equals to A. Remember that. Now the required ratio is area of the 7 quarter circles. So area of the 7 quarter circles upon area of the semicircle. This is the required ratio. So area of the semicircle. Now as we have taken the radius of this 1 quarter circle as equals to A. So as per the given data, we have that this all quarter circles are congruent to each other. And radius of 1 quarter circle is equals to A. So the area of the 7 quarter circle would be equals to 7 times area of 1 quarter circle. Now area of a quarter circle is pi radius square upon 4. And as radius is equals to A, so here it will be pi A square upon 4. So here we have got a numerator. Now let us find the denominator, that is area of the semicircle. Now area of a semicircle is pi radius square upon 2. Radius of semicircle we have taken as B. So it will be pi B square upon 2. Now we can see that pi and pi got cancelled out. From the table of 2 it goes 2. So this thing is ultimately going to be equals to 7 upon 2 multiplied with A upon B the whole square. So here we have got the required ratio in terms of variables that we have considered. Now in order to find the required ratio, we will try to find the value of A upon B. So for that, let us utilize this diagram. So here we have got a diagram. Now as all these 4 quarter circles, and in quarter circles this angle is 90 degree, that is this angle 90 degree. In this quarter circle this is 90, over here this is 90, this is 90, this is 90, this is 90 and this is 90. In all the 7 quarter circles this angle is 90 degree. Now as all these angles for 90 degree, we can utilize this thing in this particular manner. From here to here I will draw a straight line, from here to here I will draw a straight line. Now in this quadrilateral we can see that 3 angle is 90 degree, that is 90. By linear pair this is 90, by linear pair that is 90. So in a quadrilateral all the 3 angles is 90 degree, so by angle sum property 4th is 90. By linear pair this becomes 90, similarly this is 90 over there. This is also 90, that is also 90, this is also 90. So what we can observe is that this quadrilateral and this quadrilateral, all the 4 angles are 90 degree. And the adjacent side in all these quadrilaterals are equal because they are the radius of these quadrant circles that are congruent to each other. So in a quadrilateral we have all the 4 angles as 90 degree and adjacent sides are equal, so it ultimately forms a square. And in square all the 4 sides are equal, so the adjacent sides that were equal, they were ultimately the radius of this quarter circle, so they have a length that is equals to A. Now as all these quadrilaterals were square, so all the 4 sides are equal and that is equals to A. So from there we will have that this length is equals to A, this length is equals to A. I am talking about this length and this length is also going to be equals to A. This length is also going to be equals to A. This is already the radius of the quadrant circle, so directly A. Over here this is also directly A. So here we have got the required line segments. Now what I am thinking is to redraw this diagram, but this time only with the required line segments. So now what I am thinking is to label some of the points in this original diagram, so it is helpful to draw a new diagram. So this point is equals to A, this perpendicular point as B, this point as C, and this top point as equals to D. Now we will draw the same diagram. So this is the semicircle we have. Now this is the point A, this is the point C. From A to B, so here is the point B and here is the point D. So from B to D a straight line, this point is B and this point is equals to D. These are the only required line segments that we need. Now from A to B the total distance is A plus A plus A, that is going to be equals to 4 times A. So we have that AB is going to be equals to 4 times A, and from B to D the length is A plus A, that is 2 times A. So BD is going to be equals to 2 times A. So now we have that AB is going to be equals to 4 times A and BD is going to be equals to 2 times A. And this angle B is a 90 degree angle. You can just reverse the video and see in this original diagram. So angle B is a 90 degree angle. Now what I will do is draw a line segment from point A to the point D and another line segment from point D to the point C. Okay, now what can you say about the length of BC? As from A to C the total length is to diameter of this semicircle and radius of this semicircle was equals to B. So diameter is going to be equals to 2 times B. From A to B the length is already 4 times A. So BC is going to be longer minus the shorter. So 2 times B minus 4 times A would give me the length of BC. Okay, now the remaining lengths are AD and DC. So what can you say about the length of AD? As this triangle is a right angle triangle, the side is 2 times A, the base is 4 times A. So by simple Pythagoras theorem, we will get that the hypotenuse is A times square root of 20. Now similarly, we can find the length of DC. As this triangle is a right angle triangle, the side is 2 times A, the base is 2 times B minus 4 times A. So the hypotenuse is going to be equals to square root of 2 times A the whole square, so 4A square, plus the base square, so 2 times B minus 4 times A the whole square, so 4B square plus 16A square minus 16AB. So simplifying this thing will give me square root of 20A square plus 4B square minus 16AB. So this is the final length of DC. Now what I am doing is just removing this middle line from here. Now what we have is triangle ADC. The length of AD we have, that is A times square root of 20. The length of DC we have, that is this particular length. And from A to C, the total length is going to be 2 times B, that is the diameter of this semicircle. So I'm just removing this 4 times A also and this thing also. So from A to C, the total length is 2 times B. Now what can you say about this particular angle D? So we have a very nice theorem that angle inscribed in a semicircle is always 90 degrees. So let us see its quick proof. So as per the proof that we just saw, this angle is going to be equals to 90 degrees. So now we have a right angle triangle, we have the height as A times square root of 20, we have the base and we have the hypotenuse. So we can simply apply the Pythagoras theorem. So squares of the side added together. So A times square root of 20, the whole square will become 20A square plus the square of other sides. So square of this particular thing, so square and under root got cancel out. So we will directly have 20A square plus 4B square minus 16 times AB, and this thing would be equals to square of the hypotenuse. Now hypotenuse is 2 times B, so 2 times B the whole square will become 4B square. So here we can see that 4B square and 4B square got cancelled out. 20A square plus 20A square becomes 40A square, and negative 16AB shifted on the right hand side becomes positive 16AB, because here 0 is remaining as 4B square and 4B square has got cancelled out. Now here A can be factored out, so we will have that 40 times A would be equals to 16 times B. So now we can divide both the sides by 40 times B. So we will have that A upon B is going to be equals to 16 upon 40. From the table of 8, it goes 2 upon 5. So 2 upon 5 is the value of A upon B. So here we've got the ratio of A upon B. So now let us put this value of A upon B in that equation that will give us the required ratio. So here we've got the value of A upon B, and this has to be put it over there so as to get the required ratio, that is area of the 7 quadrant circle upon the area of the semicircle. Now the required ratio is going to be equals to 7 upon 2 multiplied with A upon B the whole square. A upon B has a value that is 2 upon 5. So 2 upon 5 the whole square becomes 4 upon 25. Now from the table of 2 it goes 2. So finally this thing is going to be equals to 7 into 2 upon 25, that's 14 upon 25, and that's the answer that we were looking for. So this was my way to solve this particular question. If you have any other method other than this, you can do comment below, and if it's hard to comment, you can send it to me on my Instagram or Discord. The links are in the description.